Hi, this is Jacob Nash with JNGL, and today we are looking at Unit 3, which is just the review that is about triangles. First we have 3.1, and I'm going to go through this kind of fast. The triangle sum theorem is that all the angles in a triangle will add up to equal 180 degrees. And when you have something that's like with the ratios, I meant to put a picture on here, but I forgot to. But if there's a triangle and it's like, oh, what's the ratio? And there's like three numbers and they have the colons in between them, you just add x's on all those numbers, and that's the side lengths. Or not the side lengths, the angles. So you put in the angles for those. You put in 4x, 3x, and you put in 7x. And then you would set them equal to 180, and then you would solve for x that way. And classifying angles classifying triangles by their angles. If it's equiangular, which I struggled to say on the last video that I made about this, all the angles are equal. So 60, 60, 60. That's the only possible thing. If they have to equal 180, the only thing where they can be equal is if it's 60. And acute is if all the angles are acute, then that's an acute triangle. Right triangle is if one angle is right. Why can it only be one? Well, if you think about it, like I've said this on the other video, but it's because if you had two 90-degree angles, that would just be pretty much a square. So that would not work. That would not be a triangle. So obtuse, same reason of why there can only be one, and only one is obtuse. That makes it obtuse triangle. And remember, if you don't know what acute and obtuse are, look at on Unit 2. Okay, so now we're classifying triangles by their side lengths. If it's equilateral, all the sides are equal. If it's scalene, no sides are equal. If it's isosceles, two sides are equal. Exterior angle. This is the outside of the triangle that equals the remote interior angles. So, right here, we have D. Angle D, or really ACD, if you're classifying, just forget about these right here. Just pretend this is D. Angle D is the exterior angle, and to solve, you would say D equals C plus A. Those are the remote interior angles. All that means is it's pretty much the only one that exterior angle is not touching. So it's not B. It's not going to be B. It's going to be A and C. So D equals A plus C. Unit 2 review. What do you know about these triangles? Well, looking at what we have here, you should be able to say certain things about the triangles. So we see these congruence markings for these sides. What do we know? And I wish that thing would go away. But we can find out that... Okay, I was trying to click. That angle A and angle B are equal, because we know that theorem that if we have two sides that are equal, the ones that are across from it are also going to be congruent angles. So across from this angle. Across from this angle. So they are going to be congruent. Angles A and B. What can we find about the second triangle? Well, it's the opposite. Now, what's across from this? This side length. What's across from this? This side length. That E right there, which is not being blocked by this really annoying thing. Can I drag that? No. That E is supposed to be right here. I don't know why that happened. Anyways, that E is supposed to be over at that other corner, but we find out that line DF and EF are congruent from that. Across from this is line DF. Across from this is line EF, or FE, you could say that. Alright, now from this one, what can you figure out? There's another theorem that states this. Well, if you have a line that's dividing a triangle in any way, and it has two congruent markings right there at the top of where the vertex is, this point right where that red thing's on, that's the vertex point, which is really where angle K is. You can find out that angle H and I are 90 degrees. Since it comes down here, it always will be perpendicular, which would make right angles right here. and that would help you solve. The reason why you have to know these things is they will have to assume that you know those. So they might say, oh, this is 60, this is 60, what is C? You might say, oh, well, how am I supposed to know that? There's not even A that's given. Well, you'll have to know that A is 60 because of those congruence points. Okay, I'm trying to just, all right, 3.3 review. Here's some rules. The longest side of a triangle is across from the largest side. Across meaning just like with the other things, it's just the side that if you keep drawing a line up from that vertex point. And the medium side is across from the medium angle, and the shortest side is across from the smallest angle. So the converse works also. Remember, that's just the opposite. So the largest angle is across from the largest side. So you can flip these around and they still are true. A triangle that has two smallest lengths added to equal a value greater than the largest length. What that means is if you're trying to figure out, oh, you're given these lengths, can this be a triangle? Here's what you know. Here's what you figure out. You add the two smallest lengths, and then you see, are those two lengths larger than the other length that you didn't add with? If so, then it can be a triangle. So what about this? 4 plus 5 is 9. And then is 9 greater than that 6? Yes, it is. So those three lengths could be a triangle. 3.4 review. Pythagorean theorem is a squared plus b squared equals c squared. And some common triples to know, which are things that always will work for Pythagorean's theorem. 3, 4, 5, and 5, 12, 13. Those, basically, if you see two lengths that are 3 and 4, you have to know that the next one is 5. Well, you won't have to know it, but it will save you some work. If you don't recognize that, that's okay. You can still plug in that. But it's the same thing for this one, and there's even some other ones. I think 5, 17, and 18? That might be one. Okay, but if the a squared plus b squared equals c squared, then it's a right triangle. If the a squared plus b squared is greater than the c squared, then it's an acute angle. If the c squared is greater than the a squared plus b squared, then the triangle is an obtuse triangle. 3.5 review. All right, the triangular specialties. This time I set it up a little different because the ones that have the verses between them, VS, those are ones that can be confused. And then this one on the bottom, that's pretty much one that you don't get confused with. But those can be confusing, and I'll explain the difference. So what is this one right here? Well, we see that it's coming out of the vertex point, and these are congruent, so we know that's an angle bisector. And this right here, it comes from a vertex also, but then it comes over to the other side of the triangle, and then makes it a midpoint right here. It goes over to the midpoint. That is median. And I know this isn't a triangle right here, but just pretend that there's like another side right here that connects A and B. Okay, well, what's the difference? They both seem like that they start from a corner and then they go over to the middle of a side. Well, here's the difference. The difference is that it has to come from a place that makes the angles congruent if it's an angle bisector. You can remember that because angle. But median, think median like middle. Like if you're talking about a median of a road, that's the middle. And think that it goes to the middle. That's what that means. Okay, so these over here, this, you can see that's perpendicular. This is called a perpendicular bisector. Right here, we can see that there's also some right angles that are made here. That is called altitude. What's the difference between these? Well, here's what it is. The perpendicular bisector goes through the triangle, and it makes there be a midpoint. It goes right to the midpoint, and it also makes there be right angles, and it's perpendicular. But what about this? Well, for these ones, for this example right here, that perpendicular the thing. That's not coming out right. Just forget what I said. But anyways, like it just doesn't have to be at like a midpoint really exactly. So yeah, that's what that is called. A mid segment. Sorry. It is really just a segment that begins and ends at midpoints. Well, that's kind of easy. Remember, how do you know if it's a midpoint? Well, it might say in words, or it will have these congruence markings. All right. 3.6 review. This is the indirect reasoning. And I found out that if you are taking a CP geometry, this might not even be something that you know, or something that you have to know. But I don't know. Okay, so the steps to doing that is first state what you know is false from what's given, and then state why it's false, and state what is true, which is basically restating what already was said. And when you're stating what's false, basically just oppose or contradict what was said in the other statement. For number 2, you can use an if-then statement. You don't have to, but it will ensure that you get it right. Honestly, that's the truth about that. 3.7 review. To find a missing side, find an altitude and use the Pythagorean theorem or the midpoint formula. So if you're on a graph and you're trying to find the length of the triangle, you can do a squared plus b squared equals c squared, or you can use the midpoint formula. And if you get a triangle that is like this one right here, and it's not as simple as that one, it's not a right triangle. If it's an acute triangle or if it's an obtuse triangle, you might have to draw in a line to find out what the height is. If you're trying to find the area, which is b times h, base times height, divided by 2. And the perimeter is just adding the sides. Practice question. Sorry I have none for this review because I am actually running late today with my studies because I had an event to go to today. And I'm actually preparing for some of my exams that are coming up. Well, they're in 3 months, but too bad because that's what I do. And then, yeah, good luck if you have a test. Suggestions for more help. Here's what I say. If this wasn't good enough for you, go back to the other videos I made. Or if I'm not good enough for you, then why don't you just go to a different person, like that guy who has a low voice and has black screen and draws. That guy might know what he's talking about. Well, I know what I'm talking about, but he might explain in more depth because his videos are like 30 minutes long. If that's what you need, do that. Or, just ask your teacher for help. They usually will help, unless you have a terrible teacher, but luckily I never have had one. Alright, good. And then, what city is that? Comment below. Guess what it is. My pedastro was there, and he took that picture. Alright, good. Thank you for watching, and good luck on whatever test you may have.